Hello everyone, we are Data Plus 2023 Project 19, Neurocities and Ruinscapes. My name is April.
My name is Eric.
I'm Aditya.
Our project lead is Dr. Leonard White and our project manager is John Roman. So Dr. White and his colleague Dr. Maurizio Forte are currently studying how people take in the experience of viewing an archaeological artifact, partly by studying their eye movements. Ultimately, the goal is to apply modern neuroscience technology to the study of the ancient mind, and we can do that by studying the reactions of the modern mind to ancient settings. Over the summer, we worked with the sarcophagus of the spouses and a dig site in Volci, Italy, the latter of which also involved a visual thinking strategy or VTS survey, which urges participants to think about their anticipated experience prior to viewing the site. And last thing before we get into the details, you need to know that fixations are periods of time when you maintain focus on what you're looking at, and saccades are the rapid and ballistic eye movements from one visual target to another.
For this project, we received data in the form of participant folders with video files and CSV files containing the gaze points. Here in the following images, you can see a video from the Etruscan statue, which suffers very minimal video movement. On the other hand, the Volci site video suffers from larger shifts in both scale and rotation. In this example, the participant failed to keep still and moved the head quite a bit vertically and horizontally. First, we begin by generating a reference image from all of these participant videos, either manually or via an in-house algorithm based on mean squared error, where we choose the frame that has the lowest value of this metric. Once we have this reference image, is to use an image processing algorithm that is robust to changes in scale, meaning zoom levels, and rotational changes. Our choice for the algorithm was ORB, oriented, fast, and rotated brief, combined with OpenCV's implementation of the homography module to matrix transform any gaze point on the source image into a gaze point on the reference image. Once this was achieved, this went hand in hand with a tagging tool, which allows the user to capture the features of interest on the reference image. They would begin the capture sequence with the left mouse button and complete it with the right mouse button. Then the user labels this capture and presses enter. A bounding box pops up. If a gaze point falls within the box, it will acquire the label that you gave to the box.
There are two main kinds of visualizations that we perform. The first is a heat map and the second is the scan path visualizations. In the heat map, as the name suggests, what we essentially do is plot all the gaze points as a heat map onto the reference image. In this case, the color would correspondingly indicate the density of how often a person has looked at that specific point. The second visualization that we perform is the scan path. This is essentially a video where we plot as a sort of line the last 5 or 10 points that the person has looked at. So you're essentially able to see patterns in the data. This can again be plotted on either the reference video directly or on the reference image.
We also generated descriptive statistics that are applicable to a broad range of datasets, creating a collection of CSVs and visualizations that organize the data for later analysis. These statistics are either quantitative, like fixation or saccade duration, or qualitative, like the feature that a participant most commonly fixated on. If demographic data is provided, grouped statistics can also show similarities and differences across characteristics like age and gender. Lastly, we can draw comparisons between datasets that may help us draw conclusions. For example, we may postulate that because the Volci dig site is so much larger than the sarcophagus, but both groups are given the same amount of time to observe, the Volci participants have to make shorter and more frequent fixations in order to take in everything.